Hello everyone, and welcome to the ACE Labs tutorial series on extended reality immersive analytics application development in Unity. My name is Bryson, and I'll be your guide through this series as we explore how Unity can be used not just for the creation of games, but immersive data visualization and analytics applications as well. To give a little bit of background about myself, I am a graduate student and research team manager here in the Agile Surface Engineering Lab, where we specialize in immersive technologies research. As such, our lab explores how extended reality technologies like virtual reality and augmented reality can be effectively used beyond entertainment purposes to provide valuable benefit and improvements to other fields as well, such as medicine, science, engineering, and emergency response, to name a few. If you would like to learn more about our lab and the research that we do, there is a link at the top of the description that will bring you to our website. Now, for the past 3 years, I've been developing immersive analytics applications using Unity as part of our lab's research. And I'm here today to share with you the information that you need to get started creating your own extended reality applications. To start off, you may be wondering, why use Unity to create these types of applications instead of other tools? Well, being a real-time 3D development platform, Unity and its many plugins handles lots of the nitty-gritty back-end details of developing applications for us, such as graphics and physics engines, input management, etc., so that we have to worry a lot less about the back end of setting this up from scratch ourselves. And this allows us to focus on implementing the main core features of our application and what matters the most. This saves us a lot of valuable time, money, and energy, cutting back on the development process significantly. But you may be asking, what about other development platforms, such as Unreal, for instance? Well, Unreal, although honestly being quite impressive and feature-rich itself, arguably is a fair amount more complicated and thus has a fairly steeper learning curve than Unity. This means that compared to Unity, Unreal takes more initial time to get a project up and started for those initially unfamiliar with it, which in turn means less development time. This especially has a negative impact on shorter projects, or when you bring new people into ongoing projects, where it takes more time to train them before they can actually start effectively contributing to a project. Additionally, in the past, Unity has arguably been more friendly to AR and VR development due to being compatible with more AR, VR plugins, toolkits, and other assets. I should note, though, that over time, however, this is becoming less and less the case as more toolkits and plugins are trying to target both Unity and Unreal as well. But for these reasons, our lab currently uses Unity for our application development and recommends you do so too at this time, especially if you are doing a shorter project or are new to this sort of 3D dev platform driven app development. However, this is really a personal preference, and it really comes down to what is best for both your needs and the needs of your application. For this series, though, we will be focusing on specifically using Unity for our app development. All right, so now that we have talked about why use Unity, what about how to make Unity work for developing extended reality applications? As you may already know, Unity itself is typically used to make games for computers and phones that run on screens. However, as previously mentioned, there are plugins and toolkits you can add to Unity which allow us to easily develop extended reality applications and deploy them to a variety of VR and AR devices. These are especially useful as they allow us to build a single application in Unity, but support deployment to multiple types of AR, VR devices with ease without having to build completely separate versions of an application for each device. Now, there are 3 currently leading toolkits to do so: Unity's own XR Interaction Toolkit, Microsoft's MRTK or Mixed Reality Toolkit, and XRTK, which confusingly is also pronounced Mixed Reality Toolkit. So first, Unity's XR Interaction Toolkit is nice as it's specifically made by Unity for Unity. However, it's not as feature-rich as the other two, and thus at this point in time is probably the weakest choice of the 3. MRTK, on the other hand, is a very feature-rich toolkit that allows one to very quickly and easily implement a variety of XR interactions and functionalities into any Unity application. Now, originally it targeted AR specifically with the HoloLens 1 and 2, as well as the Windows Mixed Reality VR headset later on. However, in tandem with Unity's new XR plugin management system, we can actually use MRTK with a few other plugins to deploy to pretty much any mainstream AR VR device, from the Microsoft HoloLenses and mixed reality headset to the HTC Vive, Oculus Quest, and Rift, and to my knowledge, even the HP Reverb, Valve Index, and even phone-based AR as well. These capabilities, alongside the large number of features it offers, makes MRTK regarded by many as the go-to toolkit of choice for AR/VR development in Unity. The biggest downside to it, though, is simply that it is Microsoft developed and run, and as such, they prioritize features that are best for their products, like the HoloLens 2, rather than maybe what the AR or VR community as a whole may want. And this leads us to our last choice, XRTK, which is an open source fork of MRTK and shares many similarities with it. One of the big differences and benefits of it is this open source nature, which allows for community-driven development of features and device support that aren't natively a part of MRTK. When it was first released, its biggest draw was that it supported devices MRTK did not natively support. However, as previously mentioned, nowadays there are a variety of Unity plugins that can work with MRTK to now support pretty much the same devices. With XRTK being open source and community driven, it not only gains the benefits of this, but also suffers from the downsides of this as well. Arguably, it has less frequent updates and bug fixes, less documentation of its unique features, lack of dev support, and due to its abstraction to multiple headsets, it can arguably be a bit trickier to implement when compared to MRTK. For these reasons, MRTK is the Ace Labs' current choice of toolkit for XR development in Unity, and through this tutorial series, I will be showing you how to leverage it to quickly and effectively create the XR application you desire. If you would like to learn more about each of these three options yourself, though, I have included their respective links in the description as well. Now, one last thing to note before we get started, and I begin showing you how to set all this up, is that these tutorials are targeted towards those who already are comfortable with the basics of Unity. If this is not the case for you, I highly recommend, before continuing any further in these videos, that you check out Bracky's How to Make a Video Game series, which I have linked in the description, which will walk you through all of the basics of Unity and how to make a simple application with it. Once done those, feel free to come back to this point in the video and continue forward. If you would also like a more in-depth coverage of the basics, I have included links to other good Unity basics tutorials as well. Also, my tutorials expect that you have a good grasp of C# coding already. So if you are not familiar with it or need a refresher, I have also included a link to the Bracky's Programming in C# tutorials down below as well. All right, so now that we have all that out of the way, without further ado, let's get started. So our first step is to, of course, download and install Unity so that we can get it running on our machine. To do this, we simply go to unity.com, which will bring us to their website that has all sorts of information regarding Unity and what it offers. To access the installer, simply just go to the top right-hand corner under Get Started, and that will bring us to a page with plans and pricing. Now, don't get scared off by this, as this is just for teams, industry, and companies that make more than $100,000 in annual gross revenue. For the purposes of these tutorials, we will just be using Unity for personal use, and thus we can actually use Unity in its entirety for free. If this is also the case for you, then feel free to just go down to this section on the bottom here and click Get Started. Now, this will bring us to another page that has two different options. Both install the exact same version of Unity in the exact same way. However, this has a bit of a guided learning path for first-time users, but for the purposes of these tutorials, we can simply just go over to the returning user side and click Go here. This will bring us to a final page that asks us to confirm some criteria to just make sure we're using Unity for just personal purposes. So you'll see here that by clicking on this box here, we confirm that we do not make more than $100,000 in annual gross revenue, regardless of which Unity's personal version is being used for commercial purposes or a internal project or prototyping. We have not raised funds in excess of $100,000 and do not currently use Unity Plus or Pro. So if these are all the case for you, then you can successfully use Unity's personal version for free. And so we can just click on this box here, and that will unlock this Download Unity Hub button. And by clicking on here, we can begin downloading Unity Hub. Once the Unity Hub has been downloaded and installed, you should be able to open up the application and see something like this. So Unity Hub, just to explain, is a app that allows you to keep all your Unity projects and Unity versions together in a organized manner, instead of having them spread across your computer and being hard to access. So you'll see that it defaults to the Projects tab, which has all your different projects of Unity and their respective versions. And if we go to this Installs tab here, you'll see all the current versions of Unity that are installed on your computer. If you'd like to add a version, you simply go up to the top right-hand corner, and it will bring you to this page here that gives you some options for the different release versions. For these tutorials, we will be using the most recent version of 2020.3, which is the current most recent long-term support version. Now, in the future, though, if you need a older long-term support version, or you want to use one of the most recent releases, or if you want to access literally any Unity version, you can do that through here, either with these other releases here or with their download archive that has every single version of Unity all the way back to 2011. Once you click on an option here, which since I already have 2020 installed, I'll just click on, let's say, this most recent 2019 long-term support version. You'll see some options for build support. Now, most of these are for mobile devices and various other pieces of hardware. Since we are deploying to AR and VR devices, though, the only ones that we really have to be concerned about is Android build support, which builds to Oculus, and these Windows build support options, which will build to things like the HoloLens 2 or the mixed reality headset, etc. This documentation tab, you don't really need to check, as there is plenty of documentation online, and this just sort of puts it locally on your computer. So usually I just recommend clicking these three options, and then when you click done, it will start installing. Now, if you need to install any of these modules after the fact that you install a Unity version, you can simply just go up to here and click Add Modules, and it will bring you to the same page where you can install them afterwards. But again, for the purposes of these tutorials, we will be using the 2020.3 long-term support version, and so please install that if you haven't already before continuing on in this video. All right, so now let's head back to the Projects tab. So as mentioned, the Projects tab has all of our Unity projects that are connected to the hub, alongside what version of Unity they're being developed in. You'll see these little icons next to some of them if you have a project tied into the Unity Hub, but its version of Unity is not currently installed on your computer, in which case you have a couple of options. The first is to just reinstall this version of Unity and then connect it over here. The second option is to either upgrade it to a more recent version of Unity or downgrade it to a past version of Unity. Usually downgrading ends up breaking, as the new features offered in the more recent versions aren't in the older versions. Upgrading also sometimes breaks it, depending on what was revamped or deprecated or that sort of thing. So really be careful if you're ever upgrading or downgrading, but usually the best solution of the two is to upgrade to a more recent version of Unity, unless there are big sort of changes that can end up breaking things. So it's really up to your source of judgment there, but if you can get away with still working in the same version of Unity, I'd recommend that. Now on the top right-hand corner, we can add a project that is currently not tied to Unity Hub, but is stored somewhere in your file system, whether it's because you worked on it on another computer or downloaded or something. But if we want to create a new project, we can just go over to here. If we click on this down arrow, we see all of our installed versions of Unity, and we can pick one. In our case, we're going to be using 2020.3 for these tutorials. So once I click on here, you'll see some options for templates. The 2D option is just that, for creating 2D applications for phones and screens and that sort of thing, and 2D games. The 3D option is exactly just that, 3D, and it is the old standard for 3D application in Unity. Now, Unity 2020 came out with a new rendering pipeline called the scriptable rendering pipeline, and that's where these two come in. One is targeting high-end graphics, and the other is targeting performance and not high-end graphics, but still good graphics. So it's really up to your personal preference. However, I wouldn't recommend using this old 3D template, and that's because it is eventually going to get deprecated, and thus only these will be supported in the future, from what I hear. And so essentially, in order to just make sure that your project will work long-term in the future and in newer versions of Unity, as you may want to upgrade the version of Unity you're developing in the future, I'd recommend one of these two. So if you're developing an AR/VR application that really needs high-end graphics and really good performance for high-end graphics, I'd recommend this high-definition rendering pipeline template. But if you don't need those super high-end graphics, which a lot of VR and AR applications are perfectly fine in, I'd recommend using the universal rendering pipeline, especially for performance. So for the case of these tutorials, we will actually be using the universal rendering pipeline. And so we can click on here, and then we can go over and start to give our project a name. Now, one important thing to note that no one really tells you is that Unity project file paths can get really long, so much so that they can sometimes go beyond a 256 character limit that can cause errors when running your project and you're trying to access files that are beyond that 256 character limit in their file path. And so in order to try to mitigate this, two things that I recommend are that you place where you store your Unity projects as close to the top of the drive as possible in order to lessen the overall file path that everything's going to be under, and to just not have a really long project name. So in this case, let's just go in and name our project XR app dev tutorials, and then that should be a good length. Something longer than that is probably not recommended. So now that we have our project name and our Unity projects being stored close to the top of our drive, let's go over and create our project, which will also open it up right away for us. All right, so now that we have everything open and running in Unity, we can see the default scene of our project in front of us. Now, a couple of things to note, the first of which is you may immediately notice that I have Unity set up to be in dark mode instead of the default light mode like you might be seeing. Now, to change this, we simply go to Edit up in the top toolbar here and in Preferences, and we can see in general here this part for Editor Theme, which has options for light and dark. And so if you'd like to be in dark mode yourself, feel free to switch that there. Secondly is for these tutorials, I will be using Unity's default layout with Inspector on the right-hand side, Hierarchy on the left-hand side with Project and Console on the bottom and the Scene and Game View in the center. Now, if you prefer a different layout, such as the inspector over here, or certain things on the bottom, or your scene and game view in a different window on your computer, that's completely fine. Just note that I will be using the standardized layout view for these tutorials for everyone to follow along easily. So with that, let's just play our scene and just make sure that everything seems to be running fine within Unity, which seems to be the case. And so with that, it seems like our project's all up and running all good. And let's get on to the next step, which is adding MRTK into our project so that we can start doing XR development within Unity. So to add MRTK to any Unity project, the first step is to just Google MRTK, and that will bring us to a number of links here. Now, the old way of doing so would be to access GitHub and going over to their releases section and scrolling down to the very bottom and downloading these Unity packages and adding them to Unity manually. Now, this would be done by essentially going to assets and importing the packages through here. And then just once the file explorer comes up, picking those packages and adding them into the assets of our project. However, there is a even easier way to do that nowadays, and that is using the mixed reality feature tool, which I will be showing today. So the link to that can either be found here at their GitHub page, or if we head back to MRTK's main website, which is right here, we can see at the very start here, there's a section that says, follow our installation instructions to select the Mixed Reality Toolkit Foundation package. And if we click on here, that will bring us to the Mixed Reality Feature tool. And in order to install this, to enable us to add MRTK to our Unity project, we simply just go down here and click on this link to download the latest version of the Mixed Reality Feature tool. And just go to here and click download. So once it is finished downloading, all we need to do is simply go into the folder, click on the exe to launch the tool. And it will take just a little bit of time to set up, but once it's all good to get going, we can just go down here and press start. Now, the first thing we need to do is to pick a project that we want to add the mixed reality features to. So for the case of us right now, we want to add it to the XR app dev tutorials project. And so we just find the file path in our system and go open. And yeah, so now that we have the project selected, just go discover features. And now we are presented with a list of all the different options we have for adding to our project. So you'll see some Microsoft Azure options here. You'll see the Mixed Reality Toolkit, some other platform supports, and some other options for other features here. For the case of these tutorials, we only need the Mixed Reality Toolkit options, or some of them. Specifically, we want the Mixed Reality Toolkit Foundation, and this is something that you absolutely need to have in order for the core Mixed Reality Toolkit to work. However, we can also add some extensions and some examples here. The examples has a bunch of example scenes for us, which is really nice, especially for learning MRTK, as well as we can maybe add the standard assets and the some toolkit tools here. And these are the main 5 that you really want to make sure you add. However, if you don't want some of these, you don't need to add them. The only one that you really need to make sure that you add is the Mixed Reality Toolkit Foundation here. The last thing that we need to make sure we add is the Mixed Reality OpenXR plugin. And what this will do is it will allow us to leverage OpenXR and allow us to deploy to a wide variety of headsets. This is really important. So just make sure that you select this as well. But all the other options we don't really need, at least at this point in time. If you find that in your project you might need, let's say, Azure services in the future, you can go through the exact same process and launch this mixed reality feature tool, pick your project and add these in, and it will add them in seamlessly. So it doesn't necessarily have to be at the start of this project in order to add features to a Unity project. So, but for our purposes, we just need this Mixed Reality OpenXR plugin and at least this Mixed Reality Toolkit here. We'll be using some examples, so make sure you add the Mixed Reality Toolkit examples option here. And just to cover everything, the Mixed Reality Toolkit extensions, standard assets, and tools as well. So once we've selected all those, simply go to Get Features, and it will present you with the options here. If these are dependent on anything else, it will present you with those required dependencies, and you can just select those. And then once that's done, we can begin importing them into our Unity project by just clicking down here. And once we click on there, it says that this project has been updated. Please return to Unity to import the loaded features. So we can just exit here and close this. And if we go back to Unity and click on here, we'll see that it starts loading everything in. Now, if we just wait for a second, it should go through the process of adding all of those options that we just picked into our Unity project. And this will just take a second. Once all the packages have finished importing into our project, you'll see that it comes up with this warning here. This isn't any issue, so just make sure that you press yes here, as you just want to make sure you restart the editor so that it can set everything up properly for us. Now that our project has successfully restarted, you're going to be presented with this MRTK project configurator window that will present us with a couple of different options for how we want to set up MRTK in our project. The first, it's going to ask us if we want to use the Unity OpenXR plugin that we just downloaded, or do we want to use a non-OpenXR option here. Since OpenXR is becoming the new industry standard, I recommend using this plugin, so we're going to use that for our tutorials. So you can click on here. Once that's done, it's going to bring us to a window regarding the XR pipeline settings and asking us to essentially set them up the way we want. So we just want to follow this to show the XR plugin management settings, which will open up this window right here. And you'll see that we have a number of options here. Now, this is always accessible via the project settings menu, which is just under edit. And if you go down to the very bottom, you'll see XR plugin management here. And we have a couple of different options. For our purposes, we're going to use OpenXR. And this allows us to, as again, I said, deploy to a large variety of headsets. However, you can target specific headsets such as Windows Mixed Reality or Oculus, etc. But for our purposes, we're going to be using OpenXR. And you'll see here all of our options for OpenXR. You'll notice, though, that this essentially came up with a little warning here. And if we click on it, it will bring up a menu that essentially shows a couple of different issues, but we can simply just go here and fix these. And it should resolve the issue. So in this case, let's say we want to target the HTC Vive. And so to do so, we simply just go to the interaction profiles here, click on here, and it will give us some options for a variety of different headsets. If you're wanting to do, for example, the HoloLens 2, you might want to go with this Microsoft Hand interaction profile. If you want to go to the Oculus, then you might want to do Oculus controllers or the Valve Index. In our case, we're wanting to do the HTC Vive, so we can simply click on here. And then once we've done that, we can just go back to this section here, and you'll see that it is now missing that warning because it asks us to essentially pick a interaction profile as none were picked. And these are for targeting specific devices, so make sure you always have one selected so it knows what device you are trying to target. Now we have a number of different features down here. We won't select any for now, but essentially these are important for targeting certain functionalities. So for example, for Windows Mixed Reality devices, especially the HoloLens 1 and 2, you'll see that we'll need these three features here in order to run those correctly. However, for the time being, we won't select any of these. One thing to note, though, is that for those of you that are wanting to target devices with hand tracking, especially the HoloLens 2, make sure you have this selected. But if you're targeting controllers, make sure you don't have this selected, as this will overwrite your controllers and you'll just see hands instead of your controllers when you deploy. So now that we have picked all our options here, let's just head back. And we can see in the project configurator that it has now changed and that there's this part for first time setup only. It says if you're targeting OpenXR for the first time and are targeting HoloLens 2, click the apply settings section. to apply recommended settings for it. If not, then we can just click next. In our case, we aren't targeting the HoloLens 2 for this tutorial series, and so we will just click next here. And last, it will bring us to this section here that will just ask us if we want to incorporate some of the project settings that it recommends. In this case, setting the default spatial awareness layer and enable the old input systems for input simulation are fine to do, so we can just go and click apply. And if we click apply again, it will take a sec to do so, and we'll have to restart again, so we'll just wait for that. Now that everything has started back up for us, we want to now go and test if MRTK has been set up correctly, if there's anything that we still need to tweak. Now, we could just simply add MRTK to this scene and test things here. However, this scene is missing all the MRTK prefabs and unique interactions that we want to make sure that we test in order to make sure that's been set up correctly. So instead of setting that up all in this scene, we can actually just go to one of the many MRTK sample scenes and test things there. However, the sample scenes are not natively already installed when you add all the packages. And so we need to just go and add those. So how we do that is we open up Window and go down to our package manager, and that will open up here in a second for us. And then if we head to the MRTK examples package, we can see that there is a thing here for samples. And if you go down here, you'll see that there is all these different sample scenes to just allow us to play around with all of the many features that MRTK offers. Some of them are really cool, like the scrolling object collection or the color picker. But in our case, we want to check out the controllers and the hand tracking and make sure that's all working so that we can deploy to a device successfully. So let's go and import this hand tracking demo and then go in and use that for testing. So just click on here to start that. Now that that has finished importing, we can see that it was added down here in our hierarchy. So we can just close this and head over to the demos hand tracking folder. And if we just go to scenes, you can see there's a whole bunch of different scenes for this. We just want to go into the hand interaction examples scene. You might see that this window pops up for us. This is regarding TextMesh Pro, which is a improved way of having text in Unity. I highly recommend it over the normal Unity text, and so if it just sort of asks you here to import TextMesh Pro, I recommend that as well. So we can just click on there. And let's add some examples and extras as well. All right, so now that that's all done, let's just go and check out our scene. Now, you might see all these symbols come up. Those are gizmos. And if you want to get rid of them so that they stop blocking everything that's in our scene, we can just go up here and make them nice and small. Now, you'll see here, if we move around in our Unity scene, you can see that all of these MRTK objects and prefabs are bright pink. Now, this is a sign that there's something wrong with the shaders. In fact, the reason behind this is that the standard version of MRTK uses shaders that are friendly to the old rendering pipeline and not the new scriptable rendering pipeline. However, this is very easily fixed. In fact, MRTK has a simple tool that does all this for us to adapt it to the new rendering pipeline. So if we simply go up here to the mixed reality thing on the toolbar, there is a whole bunch of options for us regarding adding and changing options for MRTK within our project. If we go under here and go Toolkit, Utilities, and go all the way down to Upgrade MRTK Standard Shader for Universal Rendering Pipeline, we can just click on here. And it will just warn us that this is a one-time thing and we can't undo this action for a project. However, in our case, this is perfectly fine. So just go to OK. And ta-da, now everything is fixed and we can see it in our scene. So now we can actually head into the scene and start testing it. So let's do that. Now that our scene is up and running, you may notice a couple of things to start off. The first is that you can rotate around by right-clicking with your mouse, as well as translate about the scene with the arrow keys. This is due to the help of MRTK's input simulator that allows you to essentially act as if you are wearing a headset and having controllers within the Unity scene without actually having to rely on hardware. And this is very, very useful for testing your project and the XR interactions without actually needing to deploy it to hardware. So this just moving around the scene and rotating allows you to just sort of simulate walking around with your headset or device. And if we want to access using controllers, we simply either just do space, which brings up the right hand here, or shift, which brings up the left hand. And we can even freeze these in space with T and Y respectively for the left and right hands. And to just get these unfrozen, we can just press T and Y to bring them back. Now, this hand here can act both as a controller for a VR device by just clicking down on it, and that sort of simulates the clicking with a trigger that you would do on these devices. And this allows you to interact with the many things in MRTK. Additionally, the hand acts also as a hand tracking simulator. So if we get up nice and close, we can essentially interact with things in Unity. So let's just go around and just make sure that all these interactions are working correctly. So here we have some manipulator interactors with some tied to physics. That seems to all be good. These allow us to move around in the scene. These touch interactions for the pinch sliders allows us to interact with these. As you saw, this piano was working. And if we go over here, these bounding boxes seem to be working. And last but not least, there's this pan and zoom panel here that seems to be working for us. And these are all MRTK prefabs and assets that allow us to have these functionalities inside our Unity project very, very easily. I will be going over these in more detail in the coming videos, but for now, it seems like all of these are working correctly. So now that we have tested our setup of MRTK with the input simulator and everything seems to be working within Unity, our next step is to make sure that our setup works on the AR or VR device or devices we wish to deploy our project to. Now, there's a couple ways to do this. The first and most labor-intensive way is to do the typical building of the project onto the device. Now, this is simply just done by accessing the build settings menu, and if you're targeting a PC or standalone VR application, you would want to go with this. However, if you're targeting, for example, the HoloLens 2 or anything that runs off the Universal Windows platform, you would want to target this platform. And then simply you would go through the whole build process with these sorts of applications. Now, this is not optimal, and the reason for this is if we want to make some changes within Unity and test them on our headset, every single time we have to build a new version of the application, which can take a lot of effort and time and waste the development cycle. The better alternative to this is simply stream directly from Unity to a headset and test things in there. Now, if you're doing this on, say, the HoloLens 2, this is really easy as it's built into the Mixed Reality Toolkit, and you would just go up here and go to remoting and click on this option here. And this allows you to basically remote directly to the HoloLens headsets when you're in play mode. And you'd have to go through a setup process regarding this. However, if we wish to deploy to a wired VR headset without having to build, one thing that we can use that I highly recommend is SteamVR. For those unfamiliar with Steam and SteamVR, Steam is a games marketplace that, as I will bring up here for you, you can see that you can play VR games within SteamVR. Now, if you don't already have Steam or SteamVR, you can simply go to this page, which is just accessed by Googling SteamVR. And if you go down here to the bottom here and say, this should either say play game or install for you, you'll have two options here. If you don't already have Steam, you can click this option. It will download Steam as well as add SteamVR for you. If you already have Steam installed, you can simply just click on this option here, and it will add or launch SteamVR for you. Once that has been all installed and launched, you should see it appear in the bottom right-hand corner. And if it detects your headset, you should see that it has just a representation of your headset's hardware at the bottom here and say it's standing by. Here you can see it's connected to my HTC Vive as well as the base stations, and my controllers are currently off. And once this comes up, we can now deploy from Unity to the headset. If you already have Steam installed and you don't want to access it from here, what you can do is simply open up your Steam, and if a headset is connected, you'll see this VR in the top right-hand corner, and you can just click on that and it will bring up SteamVR as well for you. So now that we have SteamVR up and running, the very last step we need to do is head back over to the project settings just under Edit, and it will bring up this menu that we were seeing before regarding the XR plugin management system. And if we go to OpenXR here, we can see at the top it says Play Mode OpenXR Runtime. And this I just have currently switched to SteamVR. In your case, it would look something like System Default, which would just be using the Unity input simulation system that we tested previously. And so if you switch this over to SteamVR and close this down, then once we click play, you should see that it now switches from the view that we saw in the input simulator case to now running off of our headset. One thing to just quickly note is that this should work for a variety of wired VR headsets, so the Valve Index, the HTC Vive, the Oculus Rift, and the Windows Mixed Reality. You can also get it to work via the Oculus Link capability on the Oculus Quest 2. And so you are able to essentially use SteamVR to just stream directly from Unity your project without having to build it every time to these headsets. If you are wanting to run your application standalone on a headset such as a Quest 2, you would need to go through the process of building it to that headset. Or if you're doing phone AR, for example, you'd likely need to deploy it directly to your phone in order to test it on there. But for the case of just running things during development and testing things during development, I highly recommend you go through this sort of process if you can, so that you don't need to waste valuable time building every single time you make changes. Now that we've pressed play and have our scene running in Unity, we can clearly see that we're no longer using the input simulator, but are in fact streaming Unity to our headset and using the headset and controllers to interact with objects in our scene. Now, you might notice two differences here. The first is the green and blue rectangles on the ground. Now, these are not errors. These are in fact MRTK indicating your VR play space to you. And these can be changed in their appearance or completely toggled off if you desire. And the other thing you may notice is that your controller is now replaced by 3 vectors representing the axes of your controller. Now, this is an abstract representation that MRTK uses when you are streaming from the Unity editor to your headset. However, when you deploy your application to your headset or device, the controller should be replaced by the corresponding accurate model that you would expect. So, if what you are seeing through your device looks something like this, then congratulations, you have successfully set up Unity, MRTK, SteamVR, and connected them in a way that properly deploys to the device of your choice. However, if you are having issues deploying or are seeing things differently inside your headset, or your controllers aren't properly interacting with anything around you, I would point your attention towards the XR plugin management system that we were putting settings in previously. In my experience, usually issues with deployment to the devices via the streaming method come from that XR plugin management system and settings just not properly being set there. So just go there and double check and make sure that what you have checked there makes sense for your device and you don't have anything checked that you don't need to. All right, everyone. So at last, this brings the first video in our tutorial series to a close. Thank you all for watching. Hope you learned something. Watch for bears and jackalwares, and I'll see you at the next video.